For calculus, we are now on the chain rule with differentiation. This is section 2.4 in the Larson book, the chain rule. All right, so I know you can't read it. It's a terrible copy, so let me write it down here for you. The general rule is the derivative dy over dx is equal to u times of x all of that to the n minus 1 times du over dx. Yeah, I know that helps you a lot. Oh, and this one down here generalizes it to just what I'm going to do. It says if you're taking the derivative of u to the n dx, here we go, dx of u to the n, all you do is go n times u to the n minus 1 and then times the derivative of what u is. That's all I do. I use that rule. That's really the quicker way to think about it. Let's just do that. It's quick, it's easy, it's painless. Let's stick to that. So going to an example of something that we've done already. So like if we had f of x equals 2x plus 1 squared, what we have been doing is foiling that out. So that would be like f of x equals 4x squared plus 4x plus 1. And then to take the derivative of it, then would do it. So f prime of x would equal 8x plus 4. The quicker way to do it here by the chain rule, on the original f of x function here, by the chain rule, f prime of x, you treat this as one chunk, like it's one big x, and so you put the 2 in the front, so that's 2 times that chunk, and then 1 less than it, just like we've been doing. And then you take the derivative of the chunk. The derivative of the chunk is 2. So that makes the whole answer then 2 times 2, which is 4. So 4 times 2x plus 1. So that gives you 8x plus 4. All right, so let's do some of them. You'll get quicker at it. Let's stick with this one right here, this explanation of it. So you're just bringing the n in front like we were doing before on other problems, taking 1 less on the power, and then you do the derivative of the chunk, the u. All right, so the first one here, this says 5 times 2 minus x to the third raised to the fourth. Again, this is a good place to pause after I read the problem to you, and you can try it. All right, so going over to here, y prime, again, take the power, multiply it by the number out front, that's 20, times the chunk, which is 2 minus x to the third, and then 1 less would make that 3, and then take the derivative of the chunk, and the derivative of the chunk inside here, the 2's gone, and bring the 3 in front, so it'd be negative 3x squared, and the derivative of minus x to the third is negative 3x squared, and so let's multiply these two together, so that would be negative 60 x to the squared times 2 minus x to the third raised to the third. All right. All right. So on the next one, we've got this one for the chunk. That's the big chunk. So g prime of x is equal to the exponent times the power out front. So 3 times 5, 6. So 3 times 5 over 6. Makes that 5 over 2 times the chunk. Subtract 1 from that, and that would make it negative 1, 6. 5, 6 minus 1 is negative 1, 6. And then we have to take the derivative of the chunk inside, and that's negative 9. 4 is, when you take the derivative of 4, it's 0, and the derivative of minus 9x is negative 9. And so we have these two numbers out here, so I'm going to multiply them together, so it makes that negative 45 over 2. Again, we can put a 1 underneath that so that we have a fraction and another fraction. When it's not over a number, it's always over 1. Multiply across, so that's negative 45, and 2 times 1 is 2. This has a negative power. I'm going to rewrite it by floating it down. Again, that's also over 1. I'm going to make it a positive exponent. You do that just by floating the exponent up and down, the whole chunk with it. So it makes it negative 45 over 2 times 4 minus 9x to the 1 over 6. Okay, number 20. It's hard to see, but it says negative, I'll rewrite it, negative 3 over t minus 2 to the fourth. Okay, what I'm going to do on this, I don't want to do the quotient rule on it. What I'm going to do is I'm going to float this chunk up. So floating that chunk up would make it t minus 2 to the negative fourth, because I floated it up, so it changed the sign of it to negative. So now I'm going to do the chain rule on it. So y prime, again, take the power times the number in the front, and that's a positive 12, times the chunk. The chunk here is t minus 2. 1 less than it makes negative 5. And then the derivative of the chunk is the number 1. So rewriting it here, we have 12 on the top, and we're going to float the chunk down with the negative 5. So it makes it t minus 2 to the fifth. So that's the whole answer, 12 over t minus 2 to the fifth. All right, 21 says, I'll rewrite it. It says y equals 1 over the square root of 3x plus 5. I'm going to do the same trick I did on the last one, and let's float it up. So that would equal 3x plus 5 to the 1/2. Well, negative 1/2, because I floated it up, so it's negative. All right, so again, I'm going to take that chunk for y prime, bring that chunk in front, multiply by what's in front. There's nothing there, so there's a 1. So 1 times negative 1/2 is negative 1/2. Subtract 1 from it, it makes negative 3 over 2. And then it's a negative power, so I'm going to float it down. So I'm going to leave the negative 1 on the top. I'm going to float it down, so that makes it 3x plus 5 to the 3 over 2. Ignore the banging. David's doing a chore for me. I have him putting something in the restroom, hanging up a shelf for me. It's the weekend and I'm keeping him busy. All right, 32. All right, on 32, this says g of x is equal to 3x squared minus 2 over 2x plus 3 raised to the negative 2. Well, first of all, I really don't want to mess around with the negative 2 to the whole quantity, so I'm just going to flip everything. So that flip the bottom to the top. So that makes that 2x plus 3 over 3x squared minus 2, and all that's to the positive 2. And then, I don't know, we could work it out like that. Let's see. Should we work it out like that? Yeah, let's do it. All right. Are we ready? You might want to stretch out for this one. We're going to have to use the quotient rule on it. All right, stretch out. Here we go. So g prime of x is equal to, bring the 2 out front, so it's 2 times that chunk. And take 1 less than it, so that's 1. Now we have to take the derivative of that ugly chunk. So taking the derivative of that chunk, we've got to do the quotient rule. I don't know why I put equals there. Oh, let's see. It'll haunt me. Oh, I see my whiteout. We can do this. All right. All right. Let's clean it up. All right. So again, 2 in front, take 1 less than it, and now we have to take the derivative of the chunk. So by the quotient rule, you take the derivative of the top first, and that's 2, times the denominator, then minus the derivative of the denominator, which is 6x, times the top, all over the denominator squared. All right, so cleaning it up a little bit here, I'm going to go ahead and I would leave that chunk alone for now. So we have got on the top here 2 times 2x plus 3 over, we have a 3x squared minus 2, that's on the bottom, and this one's on the bottom. So we have 3x squared minus 2 3 times. We have 1 here, because this was to the first. We have 1 here, we have 2 there, so altogether we have 3. And then, and with this mess that we have on top, let's see here. We have got 2 times 3, 6x squared minus 4. And then minus 6x times 2x would be minus 12x squared minus 18x. So on the top then, in this bracket here, I better double check it here. 6, 4, 12, 18, yeah. Well, you've got negative 6x squared. And then minus 18x. And then plus 4. I think did I lose a negative somewhere? No, I didn't. It looks good. I like it. All right. Honestly, I think you'd be okay leaving it like that, because overall what you need to do when you take a derivative is you need to worry about where is it 0 at and where it's undefined. And actually leaving it like that would make that easy enough to do. So just leave it like that. All right. And I don't know. Hopefully you don't feel too sad. We're not going to bother doing that one. There's not really room on it. Let's go down here and do a couple of these. These were kind of useful. Worrying about the parentheses on trigonometric functions. On the first one here, what you need to worry about, we're taking the cosine of this whole quantity. They don't say it, but it's over all of it. So it helps to add parentheses. So taking the derivative of it, so y prime. The derivative of cosine, remember, is negative sine. So it'd be negative sine of 3x squared. This is a chunk, because we know a rule for the cosine of x. The derivative of cosine of x is negative sine of x, but this is not a letter x. This is a chunk. So now you got to take the derivative of that chunk, which is 6x. So the whole answer on it is negative 6x sine of 3x squared. Okay, and then on the next one, this one's really upsetting for some. Remember that constant rule I talked about? I said when it's in front of it like that, that's a constant. The cosine of 3 is a constant number. It's a number. It's not a variable. There's no x in there. It's just a constant. So just leave it floating there. And so all we really have to do is take the derivative of x squared. So that makes y prime, the derivative of x squared is 2x, and then times the cosine of 3. So I guess I should put the cosine of 3 like right in there. So really 2 cosine of 3, and then the letter x. Probably ought to put that in parentheses so they don't confuse it as being the cosine of 3x. It's cosine of 3 and then times x. All right. All right. Yeah, that's fine. All right, the next one, it's the same thing. What you have to caution on the next one about is the squared that's right here. And remember to square everything. You're squaring the 3 and squaring the x. So when you square the 3, that makes 9, and then 2 x's. So it's 9x squared. A lot of times, just, you gotta clean it up. I wouldn't do the chain rule on it. I mean, you could, but that's just ugly. Just go ahead, square it. It makes 9x squared. So when you do the derivative of that, again, the derivative of cosine is negative sine of 9x squared. And again, this is not the letter x. So now you got to take the derivative of that chunk, and that makes 18x. So the whole answer on it is negative 18x sine of 9x squared. All right, and I'm thinking you probably can't see the blue ink very well. I won't do that again to you. I'll get rid of that pen. All right, on the next one, this one's good to look at. Cosine squared of x. So when it's got a 2 on the cosine, you can pull it out and say cosine of x squared. That's going to take the chain rule on it. So let's do the chain rule here. So y prime, pull the 2 out front. So it's 2 times the cosine of x. And then you got to take the derivative of the chunk here, the cosine of x, and the derivative of that is negative sine x. So the whole answer is negative 2 cosine x sine x. Okay, and the last one here, again, if you take the square root of something, just like we did with the 2 on this last one, and we did the whole thing squared, you can pull it out, do the whole thing to the 1/2. So when you take the derivative of it, y prime, again, pull the 1/2 in front, so it'd be 1/2 cosine x, and then subtract that from 1, so that would be negative 1/2. So pull it out front, take 1 less than it, and then you got to do the derivative of the chunk. And again, that's negative sine x. So all this is over 1, remember. So on the top, we've got negative sine x. And then in the denominator, we've got the 2. I'm going to float the cosine of x to the denominator because it was negative. So negative sine x over 2 cosine x to the 1/2. All right, let's do some math with it, some story problems here. Let's go down and do finding the slope of a graph. We've been working on that. It's just we're going to do it again using the chain rule. So again, this one says y equals 4 over x squared minus 2x to the third. They'd like us to find the slope when it's at the point 1, negative 4. So again, to find the slope of a curve at any point in time, at any point on the graph, take the derivative and then plug in the x. So first step here is take the derivative. Oh, I'm going to float that up too. So let's see, it'd be y equals 4 times x squared minus 2x to the negative 3. So float it up. All right, so again, taking the derivative here, this is the chunk. So take the power, multiply it by the number in front. Negative 3 times 4 is negative 12, times that chunk, x squared minus 2x. Take 1 less than the negative 3, so that's negative 4. And then the derivative of the chunk would be 2x minus 2. So cleaning it up here, everything's on the top, but I'm going to float that down to the bottom. So on the top we have negative 12 times 2x minus 2, and then over x squared minus 2x to the 4th. All right, and again we want to know what is the slope when it's the number 1. So add x equal to 1. We have got then negative 12 times 2 times 1 minus 2. And then all that's over, did I use too many parentheses? 1, 2, and then what? Yeah, I did. It'll haunt you. I'll get rid of it for you. For my OCD friends out there. There you go. All right, and then put the 1 in on the bottom. So that makes 1 squared minus 2 times 1 to the 4th. All right, and so on the top, oh, the top is gorgeous. Do you see it already? Life is good. Look at this. We've got 2 minus 2, which is 0. 0 times negative 12, 0. It's the whole thing's 0 then. And just double check though, make sure that the denominator is not 0, and it's not. Because if it was, then the whole thing would be undefined if it was 0 over 0. So the answer to all of it's 0. And again, you can check that on your calculator. So putting it in your calculator, see, y equals, we have 4, y equals, oh, I got junk to clear. All right, so y equals 4 divided by parentheses x squared minus 2x, and then close the parentheses, and that's all to the third. Well, let me look at it here. Yep. All right, graph. And again, we wanted to know when it was 1. So go to second, calculate, down to choice number 6, dy over dx. And I'm going to enter the number 1. And it says 0. So we did it right. Last one. It wants to know, determine the points on the graph of f of x equals negative 4x over the square root of 2x minus 1, where it has a horizontal tangent at. So where it has a horizontal tangent is when it has a slope of 0. A horizontal tangent means it's a horizontal line with m equal to 0 for the slope. So we want to figure out where the derivative, where does y prime or f of x prime equal 0 at? Wherever the derivative equals 0 at, that's where the slope is 0. So we're going to have to take the derivative of that function. So you could do the quotient rule on this or the product rule. It doesn't matter. I think I'm going to go for the quotient rule on it. So it's negative 4x over 2x minus 1 to the 1/2. So f prime of x. Take the derivative of the top, and that's negative 4. Then times the denominator. Then minus the top times the derivative of the denominator which would be 1/2 times 2x minus 1 to the negative 1/2. We've got a chunk going down here. So when you take the derivative of the denominator down here, here's the chunk. So you've got to pull the 1/2 in front, times the chunk, and then take 1 less than it. Then I have to take the derivative of the chunk, which is 2. And that's all over the denominator squared now. So 2x minus 1 to the 1/2, and then squared. All right, so on the top, I'm going to leave that negative 4 times 2x minus 1 to the 1/2 for now. And here, that's gone. 1/2 of 2 is 1. And we got negative 4x. Well, and a negative there. So let's just make that plus. I'll get rid of the extra minus there. So we had a negative and a negative. See, these are all quantities multiplied together over here. This, that. Those are all multiplied together. Since they're all multiplied together, you can look at the negatives over all the pieces. And there's 2 negatives, which make it a positive. And again, those are gone. And so then I'm left with 4x and then 2x minus 1 to the negative 1/2. And on the bottom, 1/2 times 2 by the power rule, 1/2 of 2 is 1. So it's just 2x minus 1 on the bottom. All right, what I'm going to do at this point is multiply the top and the bottom by 1 over, I want to get rid of this. So let's see. So if I floated it down, so it's really over 2x minus 1 to the 1/2 when I float that down on the fraction. So we got this ugly fraction over fraction going on. So why don't we get rid of that ugly fraction? So we'll multiply the top and the bottom both by 2x minus 1 to the 1/2. That will cancel that out. And I have to multiply the bottom by it too. All right, so we have 2 chunks on the top and we have a chunk on the bottom. So when you're clearing out a fraction like this, you have to multiply all the individual pieces, all the chunks, by that term. So when I multiply it by the first one here, you get negative 4 times 2x minus 1 to the first, because 1/2 times 1/2, you add the exponents, 1/2 plus 1/2 is 1. And then over here, this is the whole point of the whole thing, it cancels that chunk out, so you're left with plus 4x. And then on the bottom, 1/2 times 2x minus 1 to the first, again, add the exponents, 1 plus 1/2 is 3 over 2. All right, so it's getting a little more manageable now. So on the top then, we have got, I'll do the math on it here, we've got negative 8x plus 4, and then plus 4x. So on the top, really, it's negative 4x plus 4 over 2x minus 1 to the 3 over 2. Again, the whole point of this, and the reason I had to clean it up, is because we want to see where it's equal to 0 at, and you can't really see where it's equal to 0 until you clean it up. And where it's equal to 0 is when the top is 0. So we want to know when that's equal to 0. When is negative 4x plus 4 equal to 0? So move the 4 over, so that makes that negative 4, and then you get x is equal to 1. Again, you could check that by plugging it in the calculator. All right, I'll see you for the next lesson.